Welcome. Now in today's video I'm going to continue with this height adjuster plate for a vacuum cleaner of my mother. Now in this video we'll be doing the leftover features, which will be these two tabs here plus the cutouts for the wheels, and then this time I'll do the bushings and the shafts for the wheels as well. And then I was waiting for ball mills so that I can do cutouts with ball mills to keep the wheel axles in place, because obviously you have to draw from the top down, mill it out so that you have a rounding for the shaft to rest on. Okay, now what I've done was on this edge here in the back, that's my datum point. Now I need to cut in the slot here, which is exactly 30 millimeters from this edge here at the back. So I'm going to remove that material there. This section here is a bit narrower. So what I'm going to do now is to remove the entire section, thin it out to this dimension here. And then once I've done that, I'll turn the rotary table at angle and then do the taper feature on this end. But the most important part is to thin it out and then cut this section out in the middle here. Okay, the next feature will be this taper that I need to cut out, and it works out to 83.5 degrees. So I need to change my rotary table angle to accommodate that. Now you've seen me cut this narrower than this section here. This is 15 millimeters and this should be 11.5 millimeters. What I need to do now is to cut this side here until the bottom of the end mill touches the bottom of this riser here, and that will give me the taper on top. Took a test run here with the radius cutter, and it's way too small for the application here. So I'm gonna need to turn that, lay that rotary table flat and then do that radius using the table itself. Now, the next features will be taking the tops off to the correct height. Now I've touched off on the bottom because the bottom surface is my reference, and the top heights here will be 26, and this will be 33 at the back and 28.5. So I'm just going to skim off those features there. Next I'll be doing this feature here, which is 83-degree angle, and I need to cut it until it reaches this point here, this surface here, because in this end here it's a flat. Should actually take a little bit deeper because it's going into the midline of this top feature here. Okay, this scallop here has been cut in with the end mill. Now I need to do a chamfer here on this edge. It's 9.5 degrees. Now the machine itself has got a pipe going past here, so in order to facilitate that space that's been taken up, I need to remove that corner there. This was one of my more elaborate setups. I had to clamp the plate against 1 to 3 blocks, and the 1 to 3 blocks down onto the rotary table, and they sit on one common toe at the back. This is what the back looks like. As you can see, the clearance is quite a bit of an issue. Now with the rotary table still centered, I've used a upside down end mill to more or less center the part on this edge here. So what I'm going to do now is to replace the end mill with a 60mm end mill so that I can get clearance and cut the whole length of this round. So I'm going to back the table off towards the back, and that should give me more or less enough clearance to move or turn the table without touching my clamps here on the side, hopefully. I'm not sure about this end here, looks a bit dicey. The round came out half decent. I'm happy with it. For this sketchy setup and the fact that I can't see where I'm starting and ending, it came out pretty well. Okay, now this feels like my 100th setup on this plate already. I did already one in a vise, one on the angle plate, and about 3 setups in the rotary table. Now I'm back in the vise again, and after that I'm back into the angle plate again. So now that I need to cut out 2 recesses here for the wheels. It needs to be 40mm deep. I've marked here on top how wide it's supposed to be. So I'm going to use my roughing end mill to run through that because it's going to take quite a while. And I was going to mill out with a ball mill slots for bushings, and I decided, well, after a couple of days of pondering, I thought, now why not just drill a hole through the side here that goes through the center and just knock in a pin. Now I had some brass pins in my stock drawer, which came out of a valve, and I think it's perfect for this application. A little bit of slop is not a big issue. That should work. Then I've got other brass pieces. Get the camera to focus. Now this comes out of a normal British style plug, which we use in South Africa. And this one is also perfect because the OD is 7mm, and I need 7mm to match the pins that was in the original part. So this is 100% on size. All I need to do is to turn in a step. That's going to be 6 millimeters. That's going to go in, press into the bottom here. So yeah, my work is significantly reduced by just changing my approach to how I'm going to get the shafts knocked in. I'm going to need to change my setup here because the part is still sitting too low in the vise. I need to take down and go down another 10 millimeters. I think I've only got 4 millimeters clearance above the vise. Okay, I've moved the part to the side and dropped it down to its original depth, because now I don't have enough grip on the vise jaws to keep the part in place. So now I've dropped it down and moved it out to the side. So this setup should work now. I'm going to take my final 10 millimeter depth of cut, and that will bring me up to 40 millimeters deep. Okay, it's all done. As you can see, there's a scallop, and here's that angle where the plastic is going at the angle there. The height adjust is working, and the hooks are working. The pins are perfectly in place. The wheels are free spinning. So overall, I'm happy with it. I think this will outlast the machine. I hope you found this build interesting. So all my different setups, a million of them, but at the end, it's all worth it. Until next time, cheers.